Okay, starting off with multiple choice, question 1. Which of the following could be the graph of y equals to negative 2x plus 2? So whenever we want to try find the graph of a function, so in this case negative 2x plus 2, we want to consider the intercepts. The reason being that intercepts are easy to find, so you want to always try find the easiest method. So first of all, let's start with y-intercept. So y-intercept occurs when x equals 0, so the y-intercept is going to be y equals to 2, okay, because 0 plus 2 is 2. The x-intercept occurs when y is equal to 0. So x-intercept occurs when 0 equals to negative 2x plus 2. So therefore 2x equals to 2 and x is equal to 1. So now I know that my two intercepts are y equals 2 and x equals 1. They're both positive. And the only answer option where both intercepts are positive is answer A. So that is my answer for question 1. Moving on to question 2. Consider the following data set. Which row of the table shows how the median and mean are affected when a score of 5 is added to the data set? So, before we begin, we're looking at the old data set here, 13, 16, 17, 17, 21, 24. Let's try find the median first. So when I want to find the old median, we should notice first that there is an even number of values. And if there are an even number of data values, the median has to be the average of the middle two. And the middle two numbers are 17 and 17. So the average of 17 and 17 is still going to be 17. So my old median is still 17. Okay. Now, when I add in the number 5, that changes things because now I have an odd number of data values. And now that I have an odd number of data values, my median is simply just the middle one. And 17. So my new median remains as 17, which means that my median doesn't change, it stays the same. So let's get rid of option C and option A. Alright, because we now know that they are wrong. Now, in regards to our mean is just another way of saying average. So what's my average? Rubbing this out. Okay, what's my average? My average, or my mean, is equal to the sum of all my values. So 13 plus 16, 17 plus 17, 21 plus 24, all over the number of data values. So that's 6. Okay, now, since this is a multiple choice, we're not actually getting marked on working or anything like that. So honestly, we actually don't have to calculate this equation. This is purely just for show. So what I mean is when I add in number 5, we can see that this is significantly lower compared to the rest of my data values. And if it's significantly lower, then that means it's going to drag down my average. Right? I don't need to calculate exactly by how much it drags it down by, but I just know it's going to drag down my average because 5 is such a low number. So therefore, I now know that the mean will have to change. Right? It's definitely going to get dragged down. So my answer cannot be B, and my answer is D. Alright, so no calculations needed for the mean. You can pretty much just find out the answer just by looking at it. Question 3. Which of the following is the correct expression for the length of AB? So the length of AB here refers to this length. Okay, and we now also know that there is an angle of elevation of 26 degrees on my diagram. Alright, now, when we look at this angle, the side opposite to it is H, and the side adjacent to it is AB. What trig ratio should we think of? We should think of the trig ratio tangent. So tangent, or tan, is equal to opposite over adjacent. So in this situation here, tan 26 is equal to H over AB. And since the question is specifically asking us for the expression of AB, we now need to make AB the subject. So AB equals to H over tan 26. Now, unfortunately for us, no answer option looks like this. But we don't need to panic yet because we should remember that 1 over tan x, x is any angle, is equal to cotan x or cot x. So for AB in this situation, we have H times 1 over tan 26. That's equivalent to cotan 26 degrees. Alright, so they are the same expression or the same thing. So my answer here is B. Alright, So that's it for question 3. Moving on, question 4. Which of the following is the range of the function fx equals x squared minus 1? So what does range mean? Range basically means the possible values of y. So the interval of possible y values. Okay? So here we have the parabola fx equals x squared minus 1. That's the same thing as me saying fx equals x plus 1 times x minus 1. And if I want to sketch this graph, I have x-intercepts of -1 and 1, and I have a y-intercept of -1 as well. Because my coefficient of x squared is positive, then that means it's a concave up parabola. So pretty much it just looks like this. And if we look at this very basic and slightly messy graph, we can see that my y value, so my graph touches the y value of -1 and then goes back up. So my y value of -1 is actually the minimum value. In other words, y is going to be larger than or equal to -1 because my graph doesn't exist below this point. Okay, the graph does not exist below -1. So my range is going to have to be y is larger than or equal to -1. But unfortunately for us, all my answer options are in terms of bracket interval notation. So we have to convert this into bracket interval notation. Alright, so first of all, we should notice that there's an equal sign. In other words, the end point is included. So if the end point is included, then I have to have a square bracket for -1. Okay? And moreover, if my y value can be anything above -1, then it goes all the way to infinity. So my other endpoint has to be infinity. Therefore, my answer here is going to be A. Alright, so that's it for question 4. Question 5, moving on. Alright, question 5 is a pretty tricky one. And before we start off with question 5, so question 5 says hx equals to fx over gx. So notice here how there is two functions divided by each other. So fx divided by gx. What is the gradient of the tangent to the graph of y equals hx at x equals 1? So when we are asked for gradient, our first thought should be differentiate. Okay? Don't think of anything else. The moment you see any question have the word gradient in it, it's pretty much a differentiation question. So we need to find a way to differentiate hx. Now before we differentiate, there's a rule we should remember. That's the quotient rule. So the way I like to remember quotient rule is, if v, so differentiating that, that's equal to u dash v minus v dash u all over v squared. Okay, that is my quotient rule. So applying that to this question here, I have h dash x is equal to f dash x times gx minus g dash x times fx, all divided by gx squared. Okay, and now that that's all divided by gx squared, I now have my derivative expression. However, gradient is found by subbing in my x value. So my x value in this case is x equals to 1. So my gradient is actually going to equal to h dash 1. That's equal to f dash 1 g1 minus g dash 1 f1 all over g1 squared. And what do you know? The values are all given here. So luckily for us, we can now calculate everything. This is equal to 2 times by 8 minus 12 times by 2 over g1 squared, which is going to be g1 8 squared. Okay, so 4 times 8, oh sorry, this should be a 4. Not sure why I said 2. 4 times 8 minus 12 times 2 divided by 8 squared. That's going to equal to 32 minus 24 over 64. And that's going to equal to 1 over 8 when I simplify it. Alright, so the answer to question 5 is going to be D. Cool. Moving on to question 6. So for question 6, we probably need to make some space. So let's rub out my previous working. What is the integral of 1 over 2x plus 1 squared? I have an integral of a fraction. I tend to enjoy, or not enjoy, but I prefer to express it as a negative indice instead. So well, that's what I'm going to do first. integral of 2x plus 1 to the power of negative 2 dx. Okay, so negative indices just make it easier when we're actually integrating. But before we integrate, there's one thing we should remember, and that's what we call reverse chain rule. So if we don't remember reverse chain rule, it's basically the fact that whenever I integrate with a bracket or a composite function such as this one, I need to remember to multiply by the reciprocal of the derivative inside the bracket. So that's quite a wordy sentence. So basically what that means for this question is I need to remember to multiply by 1 over the derivative of 2x plus 1. And that's equal to multiplying by 1 over 2. Alright, that's all that is. So reverse chain rule basically tells me that I need to multiply by half in this question. So let's actually integrate now. So the integral is equal to half times 2x plus 1 to the power of negative 2 plus 1 over negative 2 plus 1 plus c. That's equal to half times 2x plus 1 to the power of negative 1 over negative 1 plus c. And that's equal to negative 1 on 2x plus 1 plus c. Okay, and if we look at our answer options, that's answer option B. So that's question 6. Question 7. Consider the following graph of a probability density function, fx. What is the value of the mode? Now, the mode is essentially defined as, for a PDF, the highest point. Another way, or another expression we can call this, is the global maximum. So we need to look for the global maximum of my PDF, and thankfully for us, the question actually gives it to us already. So this occurs when x equals pi on 4. So my mode is going to be x equals to pi on 4. My answer is C. Alright, remember it's the x value. We don't look at the y value, we look at the x value, which is pi on 4. Question 8. The graph of the even function y equals fx is shown. The area of A is going to be half, and the area of B is going to be 3 on 2, sure. What is the value of the integral of fx between negative 2 and 2? So, before we begin, we should think about what definite integral really means. So my definite integral evaluation is actually just equal to area above my graph for this interval subtracted by my area below the graph. Okay, that's what my definite integral is actually defined as. So since we are concerned of the interval negative 2 to 2, we also need to find the areas of these two intervals. And luckily for us, remember how the question said it is an even function. And if it's an even function, that means that the areas are the same. So this is half, and this is 3 on 2. Okay, so if this is half, that's 3 on 2. The area above my graph is going to be half plus half. And the area below my graph is going to be 3 on 2 plus 3 on 2. And that's therefore going to equal to 1 minus 3, which is equal to negative 2. Okay, so therefore the integral, or the definite integral from negative 2 to 2 of fx is purely just equal to negative 2. Alright, so my answer here is C. Moving on, question 9. Liam is playing 2 games. He is equally likely to win each game. The probability that Liam will win at least one of the games is 80%. Which of the following is closest to the probability that Liam will win both games? So before we begin, let's define a couple of things. We first say that P is the probability of Liam winning any game. Okay, so let's say Liam plays a game, P is the probability that he wins. And let's say Q is the probability that Liam will lose. Okay? Moreover, the question tells us the probability that Liam will win at least one of the games is 80%. So, putting this or writing this down on my page, the probability of winning at least 1%. And if we think about the complement expression to winning at least one is 1 minus the probability of winning none. So 1 minus the probability of winning none is equal to 80%. And now when I rearrange this equation, the probability of Liam winning none of his games is actually going to equal to 20%. Okay? And think about what happens when you're winning none. If you win none of your games, that means you're losing both games. So the probability of losing both games is equal to Q times Q. That's just equal to Q squared. So now we know that Q squared is equal to 20%, which is just 0.2. All right, that's our first breakthrough, really, because now I know that Q equals to square root of 0.2. And when we put that into our calculator, that's 0. Now, the probability of me losing is 0.447. So the probability of me winning is 1 minus by probability of me losing. So that's equal to 1 minus 0.447, which is around 0.55. We'll just leave it as that because nearest percentage, so 55%. Okay? Now, finally, the question is not asking us for the probability of Liam winning one game. The question is asking us for the probability of Liam winning both games. And if we try to find that, probability of winning both is going to equal to P times P, which is equal to 0.55 squared, and that's going to be around 31%. So once again, approximations. So my answer, therefore, is A. Okay, question 10, last question, multiple choice. Overall, a pretty difficult question. So the graphs of y equals fx and y equals gx are shown. So we have y equals fx here and we have y equals gx here. And the question is essentially asking us to find the graph that best represents the composite function y equals g of fx. Now, when we start this question, I think it's best that we start off with an easy value to check. So what that means is let's check x equals to 0. Right? So if we have x equals 0, what does fx equal to? So when x equals 0, f of 0 is also equal to 0. Alright? So if we have g of fx, if we sub in x equals 0, then it's going to be g of f0. And if f0 is also equal to 0, then it's going to be g of 0. So if we check the graph now, g of 0 is also equal to 0. In other words, when x equals 0, the y value of my function here is also equal to 0. So I pass through my origin. Okay, that's what it means. So looking at my answer options, unfortunately for us, all our answer options go to the origin. So it really doesn't narrow down our options much, but it is helpful to understanding what's going on. Okay, keep going though. So keep going. Now we imagine as x becomes a big number, what happens? As x becomes a big number, f of x also becomes a big number. Right, so let's say x approaches 1,000, okay, just any random number. F of x will approach something like 1,000,000, okay, a big number. So if f of x approaches a big number, then if I sub in this big number into gx, it now becomes something approaching my asymptote. Yeah, so in other words, as x becomes bigger, fx becomes bigger. And if fx becomes bigger, the y value of my composite function will start approaching my horizontal asymptote similar to what it looks like in gx. So the right side of my answer should look something similar to gx. Alright, so now looking at my answer options. Option A, it does approach a horizontal asymptote, so that's pretty good. Option B does the same thing. Option C pretty much does the same thing. It looks a little bit different, but we'll accept option C for now. But option D looks completely different. Okay, so option D is not approaching any horizontal asymptote. So therefore, we get rid of option D. Alright, now we do the exact same thing, but this time on the left side. So this time, we're going to assume x approaches a very negative number. And if x approaches a very negative number, as we can see here, fx still approaches a big number. Alright, so fx still approaches the big number and in the exact same way because it's even. Do you guys see how fx is an even function? In other words, if that's the case, so fx still approaches a big number even when x approaches a very negative number. What that means is the left side or the negative side of my graph is going to look the same as my right side. It's also going to look like it approaches an asymptote. Okay, so it's also going to look like it approaches an asymptote. So option A, the left side is different, okay, because it's on the negative. No. Option B, the left side does look similar to my right side. So therefore, option B is actually my answer. Okay, because, as I said before, even when x approaches a negative number, a very negative number, my fx continues to become a big number, so it would look similar to this. Okay, so therefore, key takeaways from question 10 is that my final solution, my composite function, is actually an even function, right? As you guys can see from the graph B, it's actually even, okay? Symmetrical about the y-axis. But that's it for question 10. Overall, a pretty tricky question. Now starting off with short answers. So here we have question 11. The table shows the type of customer complaints received by an online business in a month. And here we have a table where we have frequency, cumulative frequency, and cumulative percentage. What are the values of A and B? So if we look closely, we can see that A is underneath cumulative frequency and B is underneath cumulative percentage. Now first looking at A, so cumulative frequency essentially refers to adding up the frequencies. So what does that mean? For A, since it is in the second row, I need to add up the numbers 98 and 62. So that's going to equal to 98 plus 62, which is equal to 160. Okay, now for B, cumulative percentage, that's just essentially a percentage of the entire thing. So for B, we know that the cumulative frequency is going to be 192. And we also know that the total is 200. So for B, the percentage is going to be 192 over 200 times 100%, which is equal to 96%. Okay, so that's it for part A. For part B, the manager will address 80% of complaints, and here we have a Pareto chart that shows us the complaints. Okay, and if we look at the Pareto chart, we should notice that on the right axis, we have a cumulative percentage. So when my cumulative percentage is 80%, those are the complaints which the manager will address. So looking at this dot here, that pretty much matches up with 80%. So what does that mean? It means that delivery fee as well as stock shortage will be addressed by the manager. So what's my answer? Stock shortage and delivery fee. Okay, all that for 1 mark. And that's it for question 11. Question 12. A student believes that the time it takes for an ice cube to melt in m minutes, okay, so m stands for time, varies inversely with the room temperature, which is in T degrees Celsius. The student observes that at a room temperature of 15 degrees, it takes 12 minutes for an ice cube to melt. Okay, the key word here, which we should have highlighted first actually, was inverse. So if something varies inversely, so in this case m varies inversely with T, that means that m is equal to k over T, where k is a constant. Okay, remember this is an inverse relationship where T is a reciprocal compared to m. All right, now our job first is therefore to find what is my value of k. And how do we find this value of k? By using the initial conditions that the question gives us. Okay, so remember the question will always give you relevant information to help you out. So in this situation here, we know that when m is equal to 12, T is equal to 15. Okay, that's what it tells us here. So subbing this in, 12 is equal to k over 15. Therefore, k is equal to 12 times by 15. Okay, and now if we check what is 12 times by 15 into our calculator, that should equal to 180. So now that we found out the value of k, remember you still need to complete your last line. What is the equation relating m and t? The last line should therefore be m is equal to 180 over t. and that should be it. Okay, part B, by first completing this table of values, graph the relationship between temperature and time from t equals 5 to t equals 30. Okay, so all this is really is we're just substituting in values to find values of m. Okay, so when t equals to 5, m is equal to 180 divided by 5, which is equal to 36. Okay, so we can just sub that in straight away, 36. Now, when t equals to 15, m equals to 180 divided by 15, which is therefore equal to 12. Okay, so therefore we sub in m equals to 12. Now, when t equals to 30, that's 180 divided by 30, so that's m equals to 6. Okay, now, all we have to do is plot in those 3 points. So when t equals to 5, m is equal to 36. So I like to use a cross, okay, because crosses are more accurate because the intersection would be the point you want. When t equals to 15, which is here, m is equal to 12. So that's going to be down here. And when t equals to 30, it's going to have m equal to 6 there. All right. Now, it also says to graph the relationship between temperature and time. So we can't just be plotting points and moving on. We also need to graph the line. And if we connect the dots really basically now, it should look something like that. And do we all see how this is an inverse variation? So as we can see, as t increases, m will decrease. All right, that is an inverse variation. All right, now looking at question 13. Here we are asked to use 2 applications of the trapezoidal rule in order to find an approximate value of the following integral. Give your answer correct to 2 decimal places. Now, this is a bit of a weirdly worded question. They say here to use 2 applications of the trapezoidal rule. Now, normally for questions we are asked to use a number of subintervals or function values, but in this case they're asking for applications. So really what that means is we're going to be using 2 subintervals. Okay, they're just trying to be a little bit creative with their wording here. So what that means is whenever we deal with trapezoidal rule questions, we're going to start off with our table of values. So since we're doing 2 applications, that means we're going to have 3 function values. Okay, so let's start at 0, 1, and then we end off at 2. Okay, so these are my x values. Now, remember, y is equal to root 1 plus x squared here. Okay, so when we look at our table, when x equals 0, y is going to equal to root 1, which is equal to 1. When x equals to 1, y is going to equal to root 2, so let's just leave it like root 2. And when x equals to 2, y is going to equal to root 1 plus 4, which is equal to root 5. Okay, now we could have just done that in our head, but I just chose to write that down, but we'll just delete that now so it's not too messy. Okay, so we have our function values, that's all good. Now, when we are looking at the actual trapezoidal rule, what does it mean? So, here we have x equals to 0, x equals to 1, and this is my trapezium. So when we look at the trapezium, the width of my trapezium is equal to 1. The height, the height here is 1, the height here is root 2. Okay, so what that means is the area of my trapezium is going to be the width times by half times by the addition of your 2 heights, which is 1 plus root 2. Okay, now your second trapezium is going to have root 2 here and root 5 here, and still a width of 1. So that's going to be half times root 2 plus root 5 in this situation. Okay, so therefore my total estimated area using 2 applications of the trapezoidal rule is just going to be the addition of these 2 things here. Okay, and when we put that into our calculator, okay, we're going to put this into our calculator now, so we get half times 1 plus root 2 plus half times root 2 plus root 5 is equal to around 3.03, correct to the nearest 2 decimal points, because that's what they want us to do. Okay, and that's it for question 13. Okay, now looking at question 14, the graph of y equals k times sine ax is shown. What are the values of k and a? Now, when we have a trigonometric graph, the number in front of my sine or cosine, whatever it may be, That's the amplitude. Okay, so essentially the amplitude is how tall, how high, or how low your trig graph is going to be. Okay, so what that means is in this case here, we can all see that the height is 4 units. And the depth is also 4 units. So what that means is the amplitude is going to be 4 units here. So therefore, k is equal to the amplitude of my graph, which is equal to 4. Okay, simple as that. Now, when we have a number in front of our x, so a is a coefficient of x in this case, that's related to period. So the period of my trigonometric graph is how long it takes for my graph to repeat itself. So typically, for a sine or a cosine function, the period is going to equal to 2 pi over a. Okay, so a is the coefficient of x, remember that. So in this case here, we can figure out the period of my graph because it takes, if we can all see here, it takes 6 pi, okay, on my x-axis for my graph to repeat itself. So my period in this situation is equal to 6 pi. And now rearranging my formula, therefore a is equal to 2 pi over 6 pi, which is equal to 2 over 6, which is equal to a third. Okay, so therefore my answer is going to be k equals to 4, a is equal to a third. Moving on, question 15. So we have a bag that have 3 6-sided dice. 2 of the dice are normal dice, so 1, 2, 3, 4, 5, 6, pretty straightforward. The last dice, the third one, is a special dice that has 1, 2, 3, 5, 5, 5. Okay, now from the bag, one die is selected and tossed. What is the probability that the die shows a 5? Now, this is a really tricky question because there are 2 different types of dice, so we have to take into account 2 different possibilities when taking out the dice. So first of all, the first possibility, the first case, is that we take out a normal dice. What's the probability of that happening? 2 on 3. Okay, so there's a 2 on 3 chance of picking a random dice and taking out a normal one. Now, if we pick out this normal dice, there's a 1 in 6 chance of rolling a 5. Okay, so that's why we do 2 on 3 times 1 on 6. This is the probability of normal dice and getting a 5. Okay, so whenever we see the word and, that's multiplication. Now, we also have to add the second scenario or the second case where we pick out the special dice, which is 1 in 3 chance, and then we roll a 5. Now, for the special dice, it's actually a 3 in 6 or a 1 in 2 chance of having a 5 rolled. So that's going to be 1 on 3 times half. So this is probability of special and 5. So therefore that's going to equal to, so 2 on 3 times 1 on 6, that's equivalent to 1 on 9 plus 1 on 6. Okay, if we put that into our calculator, because we can't be bothered using mental maths, that should equal to 5 on 18. Okay, part B. Given that the die shows a 5. Okay, whenever we see this word given, our first immediate thought should be that it's a conditional probability question. Okay, so recalling the conditional probability formula, the probability of A given B is equal to the probability of A and B over the probability of B. Okay, this should be on your formula sheet as well if you guys want to reference that. Okay, but this is our number one step whenever we see this type of question, a conditional probability question. Okay, so now we are asked, what is the probability that it is the special die? So, applying the conditional probability equation to my question, the probability of my dice being special, given that I rolled a 5, is equal to the probability of having a special dice and rolling a 5 divided by the probability of rolling a 5. And here's the thing. Looking back at part A, what do we do here? The probability of having a special dice and rolling a 5 is equal to 1 on 3 times half. That's what we just said before. And we also just said the probability of rolling a 5 is equal to 5 on 18. That was our answer for part A, wasn't it? So therefore, we can just sub those values in. 1 on 6 over 5 on 18. Okay, and if we do that, that's going to equal to 3 on 5. So that's my answer. Now looking at question 16. So the parabola y equals x squared meets the line y equals 2x plus 3 at the points blah blah blah. Find the area enclosed between them. Now, whenever we deal with questions like these, we must remember the area formula for area between two curves. Okay, so the area between two curves is given as integral with lower bound a, upper bound b, fx minus gx. Okay, so therefore when we apply this to our question here, the lower bound is going to be x equals -1. The upper bound is going to be x equals 3. Moreover, on top of that, we can see here that my straight line, my y equals 2x plus 3, is on top of my parabola. Okay, so it's on top. So therefore, fx is going to be y equals 2x plus 3. Okay, so when we ask to find the area enclosed by the parabola and the line, my area formula should start off looking something like this. So 2x plus 3 minus x squared. Okay, so that's fx minus gx once again. Now, if I remove the brackets, that's going to be 2x plus 3 minus x squared. And if I integrate it now, so 2x, integral of 2x is going to become x squared directly. So x squared plus 3x minus x cubed over 3. So that's going to be upper bound 3, lower bound -1. That's equal to 3 squared plus 3 times 3 minus 3 cubed over 3 minus -1 squared plus 3 times -1 minus by -1 cubed on 3. Okay, keep going. This is equal to 9 plus 9 minus 9 minus 1 minus 3 minus -1 on 3. All right, keep going. So this is just algebra and, not algebra, sorry, math at this point. 9 minus by 1 minus 3 plus a third. And that should finally equal to, when we put this into our calculator, 32 on 3 units square. Please don't forget that unit square in the end. It is an area, so we have to include it. Okay, if it was just a definite integral, then we don't need to include unit square, but in this case here, we ask for the area. Right, and that should be it for this question, 32 on 3. Moving on. Question 17. So, cards are stacked to build a house of cards. A house of cards with 3 rows is shown. Now, we start off with 3, then 6, and then each one has 3 more cards. That should remind us here of an arithmetic sequence. So we start with 3, 6, 9, 12, etc., etc. So my first term in this sequence is a equals to 3. And since each one is 3 more than the other, I say that the common difference d is also equal to 3. So part A, show that a house with 12 rows has a total of 234. Now, this is essentially an arithmetic series. So if we record the arithmetic series formula, that's n over 2 times by 2a plus n minus 1d. Okay? So in this case here, since we now know there's 12 rows, n is equal to 12. Okay, so that's pretty helpful. Oops, what happened there? So that's pretty helpful. Therefore, this is equal to 12 divided by 2. 2 times a, which is equal to 2 times 3, plus 11 times 3. Okay, that's equal to 6 times by 6 plus 33, which when we put that into our calculator, should equal to 234. Okay, so that's using the arithmetic series formula. Once again, that should be available on your reference sheet, so there's no real need to memorize it, but I still think it's a good idea to memorize formulas like this because it's quite common and most likely going to appear in your exam. Okay, reference sheet is something that you can definitely use as a tool, but don't become overly reliant on it. Otherwise, you're going to be looking too much at the reference sheet. Anyways, another house of cards has a total of 828 cards. And this time we are asked to find how many rows there are. So it's a bit of a reverse question because once again, we still have to use the arithmetic series formula. So write that down. But the difference is this time we don't know what the value of n is. We know, however, the series formula should equal to 828. So that's the information we do know. So what do? Let's sub in all the values that we know. So we still know that a equals 3 and d equals to 3. So therefore, n over 2, 2 times 3, plus n minus 1 times 3 equals to 828. Keep going. N on 2, 6 plus 3n minus 3. Okay, so expanding that bracket equals 828. Now at this point, I think it's pretty good idea to move this 2 over to the right hand side. So let's do that while simultaneously simplifying my bracket. So therefore, I move the 2 over, so it's going to become n. So 6 minus 3 is going to be 3 plus 3n equals to 828 times 2, which is equal to 1656. Okay, so n times 3 plus 3n equals to 1656. Therefore, n times 3, so 3n, 1 plus n equals to 1656. Divide both sides by 3. We are going to get n times 1 plus n is equal to 552. Okay, we're not done yet because now, hopefully we can all see our quadratic formula. So, expanding the left-hand side, let's add a page here so we have a little bit more space. Expanding the left-hand side, we have n plus n squared is equal to 552. N squared plus n minus 552 equals to 0. So now solving for n, we're going to use the quadratic formula. N is equal to negative b plus minus square root b squared minus 4ac. Okay, so therefore negative 552 times 4 over 2. That's equivalent to me saying negative 1 plus minus square root 1 plus 4 times 552 divided by 2. Okay, and when you put that in your calculator, we should be able to get n equals to 23 only. Now, the reason why I say only here is because we don't consider the negative scenario. Why don't we consider the negative scenario? Because n must be bigger than 0. We can't have negative number of rows. That just doesn't make sense. So since n must be bigger than 0, n is equal to 23 only. So therefore, our final answer for this question is there are 23 rows in this house of cards. Question 18. So here we are asked to differentiate y is equal to x squared plus 1 to the power of 4. Now for this question, you got to be very careful. Do not forget chain rule. So what that means is, if we differentiate, we have y dash equals to 4 times x squared plus 1 to the power of 3. Now that's all good so far, but remember, what is chain rule? Chain rule basically tells us to multiply by the derivative of whatever is inside my bracket. So in this case here, we have x squared plus 1. The derivative of that is going to equal to 2x. So therefore we must multiply by 2x. So we have 8x times x squared plus 1 to the power of 3. Okay, so that's y dash. Now, part B. Hence or otherwise find the integral of x times x squared plus 1 to the power of 3. So this is 1 mark. What does that tell us? It should be fairly straightforward. Now, looking back at A, we know for a fact that x squared plus 1 to the power of 4 derivative is equal to 8x times x squared plus 1 to the power of 3. What do we notice? We should notice that this guy here looks awfully similar to whatever is inside my integral. So let's get rid of the 8. So let's divide both sides by 8. We have the derivative of x squared plus 1 to the power of 4. So dividing by 8 once again is equal to x times x squared plus 1 to the power of 3. And now if we integrate both sides, so integrate, since integration is the antiderivative, so it's the reverse process of differentiation, I can therefore say the integral of x times x squared plus 1 to the power of 3 dx is equal to 1 on 8 x squared plus 1 to the power of 4 plus c. Do not forget that plus c for indefinite integrals. But do we all see how this expression is what was inside my derivative in the first place? It's just that the integral and the differentiation cancel out with each other. Okay, so my final answer for question 18 is this guy here. Moving on, question 19. So with question 19, we are dealing with a graph of the function fx equals to x squared, and we have multiple transformations being applied to it. Now, whenever we deal with questions like these, you must remember to follow these steps in order. So here we have a translation of m units to the right. So we first say, translate m units right. That's our first step. Now, whenever we translate horizontally, so we're shifting horizontally here, we must replace every x with x minus m. So what does that mean? It basically means when we originally had x squared, so fx equals x squared, now that turns into x minus m, all squared. Okay, so that's my first transformation done. My second transformation is dilate vertically by a factor of k. Now, when this happens, we have to replace the y with y over k. Okay, so this is for dilations vertically. Therefore, originally I had y equals to x minus m squared. So remember our first transformation. Now we have y over k equals x minus m squared. So when we rearrange this, therefore, y is equal to k times x minus m all squared. All right, final transformation, we are translating 5 units down. This one is not too terrible, because now we are essentially subtracting 5 to the entire thing. Y is equal to k times x minus m squared minus by 5. But we're not done yet, okay? Because remember, the question isn't asking us to transform 3 times and finish. We are also meant to find the values of m and k. All right, because we know that whatever expression I just got, this expression here, is equal to this expression here. So first, what we're going to do is we're actually going to expand whatever answer I just got. So let's add a page down below so we have a bit more space for our working out. So let's expand this guy. Let's expand him to y equals k times x squared minus 2mx plus m squared minus 5 equal to kx squared minus 2mkx plus m squared k minus 5. Okay, now what do we notice? We notice since this thing here, this expression, is meant to resemble 3x squared minus 12x plus 7, we can just equate coefficients. Okay, that's the logic we're going to use. Equate coefficients. So, looking at the coefficient of x squared, that's equal to 3, that's equal to k. So what does that tell us? Therefore, k is equal to 3. Okay, very straightforward. Just make them equal to each other. Next, we also know that negative 2mk is equal to negative 12. So what are we going to write? Therefore, negative 2mk is equal to negative 12. Now we know k is equal to 3, remember? So therefore, negative 2 times 3m is equal to negative 12. And m is therefore equal to 2. Question 20. So here we have a scientist studying the growth of bacteria, and the equation for the number of bacteria is 200 e to the power of 0.013t. Now, what is the initial number of bacteria in the experiment? Whenever we see the word initial, we need to be thinking of when t equals 0, because that's when the start begins. So therefore, n0 equals to 200 e to the power of 0. And since e to the power of 0 is equal to 1, that's just equal to 200. Okay, part B. Now we are asking for 24 hours afterwards. So now we let t equal to 24. Therefore, n24 is going to equal to 200 e to the power of 0.013 times 24. And when we put that into our calculator, we should be able to get the answer 273.23. Okay. Part C. What is the rate of increase in the number of bacteria 24 hours after? So, when we deal with rate of increase, we need to be thinking of the first derivative. So therefore, n-t is equal to 200. So remember, this is my original NT equation. So 200 times e to the power of 0.013t times 0.013 because of chain rule. Okay, so remember, differentiating exponentials, if it's a natural exponential that you're differentiating, it should equal to itself multiplied by the derivative of the exponent. So in this case here, the derivative of the exponent is 0.013, which is why we multiply by that. Now, therefore, that's going to equal to around, or exactly 2.6 e to the power of 0.013t. And so therefore, when we sub in n-24, because 24 hours afterwards, 2.6 e to the power of 0.013 times 24. And that's going to equal to 2.6 times e to the power of 0.312, which is going to be equal to 3.552 bacteria per hour. Okay, so try to include units whenever you deal with rates of change like this. Question 21. So here we have Eli, who is choosing between two investment options. So option 1 is he deposits a single amount and earns interest on that. And option 2 is what we call an annuity, where he deposits a regular amount in a regular period of time. So option A says, what is the value of Eli's investment after 10 years using option 1? So with option 1, we are depositing at 1.2% per annum compounded monthly. Be careful about these two words, not just one word, these two words. So when it says compounded monthly, we now know that a month is going to be one period. Okay, not 1 year, it's a month. So when we look for the value of n is actually going to not just be equal to 10, it's going to equal to 10 times 12, because as I said, 1 month is one period. And moreover, the interest rate is also going to change. So before it was 0.012, now we have to divide that by 12 to get 0.001. Okay, so R is actually equal to 0.001. So now using the compound interest formula, my value after 10 years is going to equal to the principal, so 40,000, I think, times 1 plus by the interest rate to the power of the number of periods, which is 120. Okay, and when we put that into our calculator, we should get $45097.17. Alright, so that's using the compound interest formula. Just be very careful with your N and your R. Okay, I think that would trick quite a few people. Part B. What is the difference between the future values after 10 years using option 1 and option 2? So, we know the future value using option 1 because that's what we just did in part A, but now we need to find it for option 2. So for option 2, keywords, compounded quarterly. What that means is a quarter is one period. Okay, so calculating for option 2 first. Let's write that down so the marker knows what we're doing. N is equal to 10 times 4 because there's 4 quarters per year. Okay, so 10 years, there's going to be 40 quarters. And R, instead of being 2.4%, is now actually going to be 0.024 divided by 4, 0.006. Now, from here, we need to find the multiplier. So the future value multiplier can be found using the table they give us. Okay, that's why they give us the table. They don't give us the table for no reason. So, first of all, 0.006, let's look at this column therefore. The number of periods is 40, so therefore it's going to be 45.0563. Therefore, my value, or my multiplier, let's start there, is going to equal to 45.05630. So my future value of my annuity So my annuity each time is $1,000. So I'm going to multiply 1,000 by 45.05630. And that's going to equal to $45,056.30. Okay? Now, finally, what is the difference between the future values? So therefore, the difference is going to be 45056.30 minus 45097.17, which is equal to $40.87. Okay, so that's it. Question 22. Find the global maximum and minimum values of y equals x cubed minus 6x squared plus 8, where x is between -1 and 7. Now, when we are dealing with a global max and a global minimum problem, we need to be thinking of our differentiation first derivative. Okay, so what that means is our first step should be y dash equals 3x squared. Oops, not sure what happened there. Y dash equals 3x squared minus 12x. That's my first derivative. And since we are trying to look for stationary points, we should think of making my first derivative equal to 0. So if my first derivative is equal to 0, we now solve for x. So that's going to equal to 3x times x minus 4. So therefore, x equals 0 and x equals 4 are my stationary points. After this, we need to find the nature of my stationary points, whether they are maximum or minimum. And there are two ways to do this. The first way is sine table. And the second way is using the second derivative. Now, for this question, the second derivative is pretty easy to find. So in my opinion, I think second derivative is a little bit better to use. But obviously, if you want to use sine table as well, that's completely okay. But y double dash is equal to 6x minus 12. And now we sub in my stationary point values. In other words, when x equals to 0, y double dash equals to 0 minus 12, which is equal to -12. So since y double dash is less than 0, this means that my curve is concave down at this point, which therefore means that x equals 0 is a maximum turning point. Now, same thing for when x equals 4. Y double dash equals to 24 minus 12 equals to 12. So since y double dash is larger than 0, x equals to 4 is a minimum turning point because it is concave up. Okay? So now we need to double check, because the thing is, we are not allowed to now just say that these are my maximum and minimum, because these are just turning points. It does not guarantee that this is a global max or a global min. So remember, global means the biggest out of this entire interval. So therefore, there's actually two more points we need to check. The two other points we need to check are my endpoint values. We must check those as well. So my endpoint values are x equals -1 and x equals 7. So we need to check the y coordinate of those two endpoint values as well. So let's do that first. When x equals to -1, y is equal to, so looking back at our equation, y, this expression here, is equal to -1 cubed minus 6 times -1 squared plus 8, which is equal to -1 minus 6 plus 8, which is equal to -1. When x equals to 7, so my other endpoint, y is equal to 7 cubed minus 6 times 7 squared plus 8, and that's going to equal to 57. So, those are my y values for my two endpoints. I still need to calculate the y values for my max and minimum TP, so let's do that. When x equals 0, y is equal to 0 cubed minus 6 times 0 squared plus 8, which is equal to 8. And when x equals to 4, y is equal to 4 cubed minus 6 times 4 squared plus 8, which is equal to -24. Now, we should see here, this is my max TP. This is my, so let's write that down as well. So we should see here by now that the maximum point is the number 57. So my global maximum in this question is 57. Global maximum equals to 57. And my global minimum is my minimum turning point, which is equal to negative 24. So of these four numbers, negative 24 is the smallest, which is why it is my minimum turning point. That's my global minimum. Okay, so that should be it for question 22. Question 23. Here in this question, we are told that the depth of water in the bay rises and falls with the tide. On a particular day, the depth of water can be modeled by the equation shown below. Now, part A asks us to find the depth of water at low tide and at high tide. Essentially, that's the same thing as asking us what is the maximum and what is the minimum value of D. To figure that out, we need to remember that for any cosine function, doesn't matter what angle is inside, it is going to be in between 1 and negative 1. In other words, the endpoints are going to be these two values, so we have to consider those. So, when cosine 4 pi on 25t is equal to 1, what happens? D is equal to 1.3 minus 0.6 times 1. That's equal to 1.3 minus 0.6, which is equal to 0.7. Now, think about it, since we can't get any bigger than 1, this will have to be my lowest value. So in other words, low tide will occur when D equals 0.7. And when D equals 1.3 minus 0.6 times negative 1, that's equal to 1.3 plus 0.6, which is equal to 1.9. So that's going to be my high tide. Okay, part B. What is the time interval in hours between two successive low tides? Now, if we consider any cosine graph, okay, we don't need to draw it properly. If we are asked for the time between these 2 points, so two successive low tides, that's the same thing as me asking for the period. And if we recall, when we want to find the period of a cosine function, that's going to equal to 2 pi over n, where n is the coefficient of t. Okay, so in this situation, n is equal to 4 pi on 25. So therefore, we're going to say period is 2 pi over 4 pi on 25. That's equal to saying 2 pi on 4 pi times 25, which is equal to 25 over 2 hours. Okay. Part C. For how long between successive low tides will the depth of water be at least 1 meter? So, we are asking for the depth to be 1 meter. So what we're going to do is for our trig equation, we are going to say let D equal to 1, and we are going to then solve for T. Okay, so therefore, plugging this in, 1 is equal to 1.3 minus 0.6 cosine 4 pi on 25t. We move 1.3 to the other side, so we have negative 0.3 equals to negative 0.6 cosine 4 pi on 25t. Divide both sides by negative 0.6, so half is equal to cosine 4 pi on 25t. And if we recall our exact values, whatever is inside my bracket, so this entire thing, must equal to pi on 3. Okay, so remember, cosine pi on 3 equals to half. So therefore, pi on 3 must be equal to 4 pi on 25t. Now, since we are also asked for this question for successive low tides, we must also consider the fourth quadrant angle. Okay, so that means we also have to consider, so 2 pi minus pi on 3 is 5 pi on 3. Okay, so therefore, our two solutions for t are going to be, when we rearrange the equation, pi on 3 times 25 on 4 pi, or pi on 3 times 5 pi on 3, times 25 on 4 pi. Okay, and that's going to equal to 25 over 12, or 125 over 12. Now, we can't stop there, unfortunately. It does say for how long between. So we're not asked for the times that it occurs, we are asked the time in between them. So what do we have to do for our last step? We have to say 125 over 12 minus 25 over 12 equals 25 over 3 hours. And that is our final answer. Question 24. So here we have Joe, who is researching the relationship between the ages of teenage characters and the ages of the actors who play these characters. After collecting the data, Joe finds that the correlation coefficient is 0.4564, and a scatter plot of the data is drawn. This is what we can see below. Okay, now the question asks us, describe and interpret the data and other information provided with reference to the context given. And a very important thing to note for question 24 here is that it's worth 4 marks. So what that means, for 4 marks, you need to include at least 4 major points about the data. So that's going to be our goal. Okay, because if you don't include 4 major points, the marker will be less inclined to give you 4 out of 4. So we want to try and include as much detail and as many points as possible. So the first thing we notice here is that my line of best fit is increasing. And it's also a line. So what that means is, for us, that's going to be a linear and positive correlation. Okay, that's our first and hopefully most obvious point. After that, we also realized that they told us that the correlation coefficient is 0.4564. Now, this is neither strong nor weak, so we're going to call this a moderate correlation. So because correlation coefficient, or coef for short, is 0.4564, it is a moderate correlation. Okay, so not a very strong relationship, but not weak either. On top of that, we also see that they give us the equation of the line of best fit, so we should probably use this information as well. Now, if we look at this equation, we see that it's going to be plus 1.85x. What does that mean? It basically means as the age of my character increases, so as x increases by 1, y will increase by 1.85. Okay, so approximately 2 years. So we were going to say, in relation to this context, as age of my character increases by 1 year, the actor's age tends to increase by approximately, okay, so we should say approximately 2 years. Okay, and if you guys really want, we can also put in brackets around 1.85. That's just to show our marker we've been talking about, or we are referencing specifically the line of best fit equation. Okay, moreover, on top of that, we only have 3 points right now, so we need to keep going, right? Keep looking at the data. When we look at the data, we should notice that this is where the data tends to be concentrated. Okay, so for the age of 15, there's a lot of data points. So what does that mean? It means that this is the largest group, or pretty much the mode. Okay, so we say here, so let's scroll back up so we can see the data. Characters of age 15 are, or is, the largest group. And on top of that, it's also played by actors who are aged from 14 up to around 27. Okay, so, and are played by actors aged 14 to 27. Okay, now we have 4 points now, but it doesn't harm to include one more. So another thing we can notice as well is our y-axis values are very different to our x-axis values. So what does that mean? It basically means when the age of my character is meant to be 14, we have, 18-year-olds playing them, 22-year-olds playing them. When the age of my character is meant to be 16, we literally have 19-year-old as the minimum age of the actor playing a 16-year-old character. So that's another point we can make as well. We can say actors playing teenagers are much older than the character is meant to be. Okay? And hopefully with 5 points or 5 major points where we've referenced all the detail they've given us, that is sufficient to get 4 out of 4. Okay, so for this question, we have to remember to include as much detail and as many points as we can. All right, that's to maximize our marks. Moving on. So, question 25. Here we are given fx, which is equal to sine 2x, and we are asked to find the value of x, for which f dash x equals negative root 3 and f double dash x equals to 2. Now, since we see that we have to deal with derivatives, let's just differentiate first. Okay, so get that out of the way. So if fx equals sine 2x, f dash x is going to equal to 2 times cosine 2x. So remember, we need to include that extra 2 because of chain rule. Okay, and if I differentiate again to get the double diff, that's going to be negative 2 times sine 2x times by 2 again because of chain rule, which is equal to negative 4 sine 2x. Okay, now let's now look at the information they give. So f dash x is equal to negative root 3. So f dash x equals to negative root 3. We now know what f dash x is. So negative root 3, is equal to 2 cosine 2x. So therefore, cosine 2x is equal to negative square root 3 on 2. And if we recall our exact values, which hopefully we can do, we should remember that cosine pi on 6 is equal to square root 3 on 2. Okay, so since this is a negative angle for, or negative value for cosine, that must mean it's in the second and the third quadrant. Alright, so it's in the second and third quadrant. So what that means is, therefore, 2x equals to pi minus pi on 6, or pi plus pi on 6. So remember, second or third. So if 2x equals to x minus pi on 6, that's going to equal to 5 pi on 6, or 7 pi on 6. Okay, so that's 2x. Now, since we are concerned with x, we should divide both sides by 2. X is equal to 5 pi on 12, or 7 pi on 12. Okay, so that's my 2 possible values of x for now. Okay, now, next, we are also told that f double dash x is equal to 2. So what that means is, negative 4 sine 2x is equal to 2. And if you divide both sides by negative 4, sine 2x equals to negative half. So once again, recalling our exact values, we should remember that sine pi on 6 equals to half. And since the value of sine 2x is negative here, it must be in the third and the fourth quadrant. Okay, so therefore 2x equals to pi plus pi on 6, or 2 pi minus pi on 6, so third and fourth quadrant. And that's going to equal to 7 pi on 6, or 11 pi on 6. Okay, so 2x equals to that, therefore x is equal to 7 pi on 12, or 11 pi on 12. And when you look at these solutions, so looking at this set of solutions and looking at this set of solutions, there's only one common value between them, and that's going to be 7 pi on 12. So hence, my answer has to be 7 pi on 12 only. So let's write that down. Hence, since f dash x equals negative square root 3 and f double dash x equals to 2, x must equal to 7 pi on 12. So that is my final answer. Question 26. So here we are told that the lifespan of batteries is normally distributed with a mean of 840 hours and a standard deviation of 80 hours. So our mean here is 840 and our standard deviation is 80 hours. It is known from statistical tables that for this distribution, approximately 60% of batteries have a lifespan of less than 860 hours. we are asked to calculate the approximate percentage of batteries with a lifespan between 820 and 920. So the first thing that should stick out is the fact that we have a normal distribution. So we should be graphing our bell curve here so we get a better understanding of the question. So 840 is here, and our standard deviation is 80. The next thing we notice here is that 920 is conveniently one standard deviation above the mean, because 840 plus 80 is equal to 920. 840 minus 80 is equal to 760. So what that means for us is that using the empirical rule, we now know that this area here is 68%. Okay, and if we know that that's 68%, it actually does help us quite a bit, because we are then asked between 820 and 920. So 820 is going to be somewhere here. So we are eventually going to find this area, but obviously we don't know what to do just yet. But remember that the question gives us an additional piece of information. We should try use that. So once again, drawing my bell curve, we are told that a lifespan, so this is my mean, 840, a lifespan less than 860 is a 60% chance. So this area here now is 60%. And we should all notice that 860 is 20 more than 840. So since my bell curve is an even function, bell curve is even, we can also sketch the fact that for my bell curve, if I have 840 here, I have 820 on the left, and 60% of batteries will have a lifespan more than 820. So because my bell curve is even, repeating myself once again, this area must be equal to this area. And that's actually very helpful for us, because now I know for a fact that this entire area is 60%. And going back to my original empirical rule, since this middle chunk is 68%, then that means this side chunk here, which I'm going to highlight in orange, this chunk here, that's going to equal to 100 minus 68 divided by 2. I need to divide by 2 because I need to split it evenly with this side. Okay, so that's why we divide by 2. That's equal to 16%. So in other words, what that means is, the question is essentially asking us to find, so this is 820, and this is 920. So the question is asking us to find this orange area here. Okay, so there's a lot of diagrams for this question, but that's just so we can understand what's happening. We know from this graph that this is 60%. Okay, so if we insert into this graph here, let's write in blue pen, 920, we know from this original graph for the empirical rule that the orange area is 16%. So this entire area here is going to be 16%. So in other words, this part is 16%. So this part has to be 60 minus 16%, which is equal to 44%. And that's going to be my answer. 44% of batteries have a lifespan between 820 and 920. So overall, this is a pretty hard question. I would definitely recommend we draw our bell curves here to help us understand what is going on. Okay, because we have to use a lot of different calculations and perspectives. Question 27. Here we have the function fx equals x times e to the power of negative 2x. It is given that f dash x equals to this thing here. Show that the double derivative is equal to 4 times x minus 1 times e to the power of negative 2x. So when we look at the double derivative, that means we need to differentiate f dash x again. So let's do that here. F double dash x is equal to the derivative of e to the power negative 2x minus 2x e to the power negative 2x. Okay, so differentiating that, we need to remember to use chain rule here. So when we differentiate e to the power negative 2x, we need to use chain rule, so that's going to be negative 2 times e to the power negative 2x. And then we also need to differentiate 2x e to the power of negative 2x. Now, this is quite hard. Let's factorize out the 2, and then we should be able to see something here. We should be able to notice that this derivative is essentially fx. So we don't need to use any product rule or chain rule to evaluate this because it's actually already given to us. So we already know that this derivative is equal to this guy here. So therefore, we can swap it out to have negative 2 times e to the power of negative 2x minus 2x e to the power of negative 2x, because that's given to us, thankfully. Okay, and then expanding my bracket, that's equal to negative 2 e to the power of negative 2x minus 2 e to the power of negative 2x plus 4 x e to the power of negative 2x. And that's equal to negative 4 e to the power of negative 2x plus 4x e to the power of negative 2x. And once again, 4 times e to the power of negative 2x, x minus 1. And that's my answer. Okay. Part B. Find any stationary points of fx and determine their nature. So, stationary points means that we must consider the first derivative. So, stationary points occur when f dash x equals 0. So, once again, looking at the derivatives, we let e to the power negative 2x minus 2x e to the power negative 2x equal to 0. From here, we can factorize out e to the power negative 2x to get 1 minus 2x equals 0. Now, since an exponential can never equal to 0, there is only one solution here. And that one solution is going to be that x equals to half. So therefore, x equals half is a stationary point. And if x equals half is a stationary point, don't forget that we also need to determine the nature. Okay, so the nature of a stationary point is determined by either using a sine table or the double derivative. And for this question, since we've already evaluated what the double derivative is, we might as well use it. So, when x equals to half, f double dash half is going to equal to, so once again looking back at our double derivative equation, that's going to equal to 4e to the power of negative 2 times half, bracket half minus 1. That's going to equal to negative 2 times e to the power of negative 1. And that's going to be a negative number, so less than 0. And if it's less than 0, that means it's concave down. And therefore, x equals half is a maximum turning point. However, we can't stop here because it does ask us for the stationary point. Okay, so what that means is we need to remember to include my y value. So when x equals to half, remember that my fx was equal to x times e to the power negative 2x. So therefore y is equal to half times e to the power negative 2 times half, which is equal to half e to the power negative 1, which is equal to 1 over 2e. So therefore, my stationary point is half and 1 over 2e. That is a maximum turning point. Alright, so do not forget to evaluate the y value as well. A lot of the times in the heat of an exam, people will forget, so it's good practice to remember to do this in your trial exams. Part C, sketch the curve y equals x times e to the power negative 2x, showing any stationary points of inflection, and intercepts with the axes. Now, when we sketch a curve, we need to usually follow a method. Okay, so first of all, we know what the stationary points are. We've already evaluated that. Do we know the points of inflection? Not yet. Do we know the intercepts? Not yet. So before we try sketch the curve, it is a good idea to first find out where my points of inflection and where my intercepts are. So let's start with the intercepts, because intercepts are easy to find, so we might as well do that first. So finding intercepts. if I let x equal 0, y is going to equal to 0 times e to the power of 0, which is just equal to 0. So therefore, my intercept is going to be the origin, 0, 0. That was pretty easy. Okay. Next, point of inflection. When does the point of inflection occur? So point occurs when the double derivative, f double dash x, is equal to 0. So scrolling back up to my question, f double dash x was equal to 4 times x minus 1 times e to the power of negative 2x. So 4 times x minus 1 times e to the power of negative 2x equals 0. And as we can see here, point of inflection should occur when x equals to 1. Okay? However, we must remember that this is not always the case. So a point of inflection does occur usually when double derivative equals 0, but it's not always the case. So just to be safe, we need to include a sign table to double check. So sign table, what that means is I'm going to have x on one row and I'm going to have the double derivative on the next row. So I'm going to put in 1, I'm going to put in 0, I'm going to put in 2. Okay, so remember, a sign table just essentially checks for me whether or not there really is a change in concavity. Okay, if there is a change in concavity, then that means this is a point of inflection. So if I put in 0 into my double derivative equation, I'm going to get 4 times negative 1 times e to the power of 0. That's equal to negative 4. What does that mean? It means that it's concave down. Okay, we know that when x equals 1, double derivative equals 0. Now, when I put in x equals to 2, that's going to get me 4 times 2 minus 1 times e to the power of negative 4. That's just going to equal to 4 e to the power of negative 4. And since that's a positive number, that means it's concave up. So therefore, a change in concavity does occur. And since a change in concavity does occur, therefore, x equals 1 is a point of inflection. Okay, and remember, since we are asked for a point, we also need to figure out what the y value is. So once again, looking back at the fx, if we let x equals to 1, then my y value is going to be 1 times e to the power of negative 2. Okay, so just write that down now, down here. X equals 1, y equals e to the power of negative 2. Okay, that is a point of inflection. Cool, so that's all our prep work done. So all our points now we know of. So now we can finally sketch our graph. So drawing our coordinate axes in, x and y, and 0. Okay, so first of all, we know that the intercept, that the graph goes to the origin. So let's put a point there. Second of all, we just figured out that 1 and e to the power of negative 2 is a point of inflection. On top of that, we also figured out in part B that this point here is a maximum turning point. Maximum turning point. So let's put that in as well. Half and also 1 over 2e. So that's going to be above. So that's going to be around here. Okay, obviously this graph is not to scale. Okay, so these are 3 main points. Now, let's sketch the graph in blue so we have a little bit clearer working. So first of all, this part of the graph has to go down. There's no question about it. Right? It can't go back up because we know it's not a turning point, so it has to go back down. Second of all, this part here has to be a maximum turning point. So we know that it reaches there and goes back down. And finally, this part here is a change in concavity. So it's going to look something like that. Let's redraw that because that one didn't look too great. And that's going to be my answer. Okay, so this is a point of inflection here. This is a maximum turning point. And this is my origin that I go through. Right? Obviously the graph is not the best in terms of looks, but as long as it gets the point across and you show the marker what your main points are, which we have done in this situation, then that should be it. By the way, the reason why we approach the x-axis like an asymptote here is because we know that there are no other x-intercepts. So because there are no other x-intercepts, we are not allowed to touch the x-axis. Right? Hopefully that everyone can see that. Okay, so since we are not allowed to touch the x-axis, we have to approach it like an asymptote. All right, so that's why line. Cool, and that should be it for question 27. So overall, pretty challenging one, especially with the sketch. Question 28. So here we have the graph of the circle x squared plus y squared equals to 2. And we have an interval connecting the origin and the point 1, 1. So part A asks us, by considering the value of theta, find the exact area of the shaded region. So the shaded region is this region here. And we are tasked with first finding the value of theta, okay, because that's the hint the question gives us. So looking at the triangle, the right angle triangle here, we see that the x and y coordinate is both 1. So 1 and 1. Now what that means is if I have the opposite side is equal to 1 and the adjacent side is also equal to 1, then that means that tan theta is equal to 1 over 1. So therefore, theta equals to pi over 4, okay, or 45 degrees. Alright, so that's the first step we should probably do, because the question does tell us to consider theta. After that, we see that the shaded area, hopefully we can all see this, is the area of the entire sector minus by the area of the right angle triangle. So let's write that down. The shaded area is equal to area of sector minus by area of my triangle. So looking at the area of the sector, we should record that the area of a sector is equal to half r squared theta. And that's going to be subtracted by the area of a triangle, which in this case is just going to be 1 times 1 times half, which is just going to be half. So therefore, the area of a sector is going to be half times the radius squared. Now, we know that the equation of my circle is x squared plus y squared equals 2. So my radius must equal to root 2. So my radius squared must equal to 2. Okay, so therefore that's going to equal to half times 2, half times 2 times by theta, which we now know is pi on 4. Remember, for this equation, when we deal with the area of a sector, we must remember to leave theta in terms of radians only. Okay, it can only be in radians. And that's going to be subtracted by half. That's going to equal to pi on 4 minus by half units squared. Okay, we can't simplify this any further, so we leave our answer like this. Okay, so don't forget the unit squared as well. Moving on. Part B. Part of the hyperbola which passes through the points 0, 0 and 1, 1 is drawn with the circle as shown. So now we are asked to find or show that A is equal to B, which is equal to 2. So first of all, we should notice here that when x equals to 0, our y is also equal to 0. Okay, so remember, the equation of my hyperbola is y equals a over b minus x minus 1. So therefore, 0 is equal to a over b minus 0 minus 1. Therefore, moving the negative 1 to the other side, 1 is equal to a over b. So a must equal to b. Okay, that's a pretty helpful piece of information. Next, we also know that when x equals to 1, y is also equal to 1. So when x equals 1, y is also equal to 1. Therefore, 1 is equal to a over b minus 1 minus 1. 1 to the other side, 2 is equal to a over b minus 1. Therefore, a is equal to 2 times b minus 1. Alright, and remember how a was equal to b? We can implant this or substitute this into this equation. So therefore, b is equal to 2b minus 2. Therefore, if I rearrange it, b is equal to 2. And since a is equal to b, a must also equal to 2. And that's going to be my answer. Okay, so therefore we have shown that a equals b equals to 2. Part C. Using parts A and B, find the exact area of the region bounded by the hyperbola, the positive axis and the circle as shown on the diagram. Okay, first of all, before we start, we now know the equation of the hyperbola. So let's write that down first. Y is equal to 2 over 2 minus x minus 1. Okay, now in my previous part, so for part A, we already found the shaded area. So the shaded area, if we look at our diagram, the shaded area is essentially this part here in red. So we already know that this area is going to be pi on 4 minus half. So now our job is to find the rest of my shaded area, this blue area here. And luckily for us, that seems to be the area underneath my hyperbola. So when we think of that, we now need to think of integration. Okay, so we need to find the area underneath my hyperbola with the bounds of 0 and 1. Okay, so let's write that down. So area is equal to the integral from 0 to 1, 2 over 2 minus x minus 1 dx. Okay, now we need to integrate. So our x is on the denominator here for my integrand. So what that means is, since x is on the denominator, we need to think of a logarithmic integration. So integrating to logarithms. 2 is going to be on the outside, so that's going to be 2 times ln, absolute value, do not forget the absolute value, 2 minus x times negative 1. We must times by negative 1 because of reverse chain rule. So remember, what's the derivative of 2 minus x? The derivative is negative 1. So therefore we must times by 1 over negative 1, which is negative 1 still. Okay, so we need to remember to include that negative, otherwise our entire working out is wrong. And then this one, so the next step is integrate negative 1. That's easy enough, that's just negative x. And now we have bounds of 1 and 0. 1 and 0. So that's just going to equal to negative 2 ln, absolute value 2 minus x, with bounds of 1 and 0. We are running out of space here a bit, so let's add a page to help us out. And now putting in my substitution, negative 2 ln, 2 minus 1 minus 1, minus negative 2 ln, 2 minus 0 minus 0. Okay, so now we've substituted everything. This is equal to negative 2 ln 1 minus 1 plus 2 ln 2 plus 0. And since ln 1 is equal to 0, we can cross that out. And hence we finally have 2 ln 2 minus 1. So this is the area underneath my curve. So total area is therefore going to be, as we said before, area underneath my curve, so 2 ln 2 minus 1, plus our pi on 4 minus half, which we found out in part A. Okay? And that's going to, don't forget the unit squared, and that's going to equal to 2 ln 2 plus pi on 4 minus 3 on 2 units squared, and that's it. Okay, so we leave our answer as an exact area as the question wanted us to. Question 29. So here we have a diagram that shows the graph of y equals 2 to the power of negative x. Also shown on the diagram are the first 5 of an infinite number of rectangular strips. Now each strip is a width of 1 unit, and the height is going to be relative to y equals 2 to the power of negative x. So, part A. The sum of the areas of rectangles form a geometric series. Show that the limiting sum of this series is 2. So essentially we are asked to find the total sum of all rectangular areas in this diagram. So, the first rectangle that we notice is a width of 1, and also it has a height of 1. So the area is going to equal to 1. The second rectangle, the height is only going to be 2 to the power of negative 1, which is going to be half. And the width is still 1, so the second area is going to be half. The third area has a height of power of negative 2, which is a quarter. So the area is going to be a quarter. And hopefully by now, we should be able to see this pattern, where it's 1 plus half plus a quarter plus an eighth plus dot dot dot. Okay? Now, this is a geometric series where a, the first term, is equal to 1, and r, the common ratio is going to equal to half. So if we are asked for the limiting sum, record that the limiting sum equation is a over 1 minus r, and that's going to equal to 1 over 1 minus by a half. Okay, so therefore in this case here, that's going to equal to 2. So the limiting sum of this series is just 2. Part B. Now, we are asked to integrate an exponent. Now this is a pretty tricky question because the exponent in this case is not with a base of e. Okay, so if it's a base of e, it's usually much easier. But in this case, unfortunately for us, it is not. So, looking at our formula sheet, our reference sheet, we should be able to see that the equation, so the direct integral of 2 to the power of negative x dx is equal to 1 over ln2 times negative 2 to the power of negative x. Now, the reason why we need to include the negative here is because of reverse chain rule. So, the derivative of negative x is equal to negative 1, and the reciprocal of negative 1 is still negative 1, which is why we have to multiply the entire thing inside my bracket by negative 1. Okay, so if that's the case, we now have negative 1 on ln2, 2 to the power of negative x with bounds of 4 and 0. So subbing it in, that's negative 1 over ln2, 2 to the power of negative 4, bracket, minus negative 1 over ln2, 2 to the power of 0. Okay, and that's going to therefore equal to, so moving down the page to where we have more space, negative 1 on ln2 times 1 over 16 plus 1 over ln2. Okay, so that's going to equal to 1 over ln2 minus 1 over 16 ln2, which is equal to 15 over 16 ln2. And that's going to be what I was required to do. So that's my answer. Okay, 15 over 16 ln2. So remember, the tricky part of this question was finding the integral of 2 to the power of negative x. But if we use our formula sheet, we should be able to see the general formula. That's going to be 1 over ln a times by negative 2 to the power of negative x. Okay. Part C. Use parts A and B to show that e to the power of 15 is less than 2 to the power of 32. So this question is quite weird because we really don't know where to start. Okay, because, you know, this inequality kind of came out of nowhere. So we need to kind of think, hang on, what can I do? What can I use? So the question does say to use part A and B, but that doesn't tell us much. But in general, for any rectangle question, so questions like these are actually decently common, more so in 3U maths than 2U maths, but still quite common in Maths Advanced papers. But in general, we should be able to notice here that the area of my rectangles are far greater than the area underneath my curve. Area of my rectangles, we should notice, overestimate the area. Let's write that down. So area of rectangles overestimate the actual area. Because remember, the definite integral represents actual area underneath a curve. So that means, so here we have an idea now. We have an idea where we can create an inequality here, where we basically say the area of my rectangles is larger than the area underneath my curve. Okay, so the area of rectangles is larger than area underneath curve, or in other words, the integral. So that's where this idea comes from. That's the thought process behind this question. I think it's very important, especially for a tricky question like this one where we don't have many clues. Okay, so therefore, area of rectangles, we found that out in part A, didn't we? We found out that that was equal to 2. So 2 is larger than the entire area underneath my curve. But here's where the problem is. In part B, we did not find the actual entire area underneath the curve. We only found the area underneath the curve for a certain part. Okay, so between 0 and 4. But the thing is, that doesn't actually impact us, because the area and the entire area underneath my curve is bigger than the area from 0 to 4. So this inequality is still true. Because if you think about it, if A is larger than B, and B is also larger than C, then it's entirely fine for me to say A is larger than C still. So in this case, I can still say 2 is larger than the area underneath curve from 0 to 4. Okay, and this is good for us now because B. Okay, now we can use our answer from part B, which we know is 15 over 16 ln2. So therefore, I can say 2 is larger than 15 over 16 ln2. And now simplifying everything by multiplying both sides by 16 times ln2, we have 32 ln2 is larger than 15. And then we have, so 15 is less than 32 ln2. So if we make both sides the power of e, so e to the power of 32, oh, let's write that again, 32 ln2 is larger than e to the power of 15. And from there, notice that using our logarithm laws, I can bring this 32 into here. So that's going to now become e to the power of ln 2 to the power of 32. Okay, so power of 32. Okay, so pretty confusing, but that's using our logarithm laws, is larger than e to the power of 15. And once again, using log laws, we can simplify my left-hand side to simply become 2 to the power of 32 is larger than e to the power of 15. And that's going to be my answer. Okay, so pretty tricky question overall, especially with starting the actual problem itself. And then we also had to realize that we had to use two logarithmic laws to solve this question. Question 30. A continuous random variable x has cumulative distribution function given by capital Fx. Part A asks us to show that k is equal to 3, and we should see that k is in this equation here. So when we are looking at a CDF, which is in this question, we need to consider that for the endpoint interval of my x domain, so in this case e to the power 3, f of e to the power of 3 must equal to 1 for a CDF. The reason is that the maximum probability something can have is 1. So therefore, we say that when x equals to e to the power 3, the function is equal to 1. Therefore, summing that into our equation, 1 on k ln e to the power 3 equals 1. 1 on k times 3 equals 1. So therefore, k must equal to 3. Okay, so that's for 1 mark. Part B. Given that the probability of x being less than c equals to 2 times the probability of x being larger than c, find the exact value of c. Now, when we are asked for the probability of x less than c, that's the same thing as me saying capital FC. So capital F stands for the CDF. Now, when we are asked for the probability of x being larger than c, this is a little more complicated because now we have to consider the complement. The complement to this is 1 minus the probability of x being less than c, and that's going to equal to 1 minus capital FC. So now substituting these new variables in, therefore, swapping it out, FC equals to 2 times 1 minus capital FC. So FC equals to 2 minus 2 times FC. Therefore, 3FC equals to 2, and therefore capital FC equals to 2 on 3. So now we are tasked with finding the value of c. So remember that we figured out from part A that k is equal to 3. So what that means is that my equation for fx is actually 1 on 3 ln x. So now we need to solve for x if fc equals to 2 on 3. So now we say, therefore, let's write it here, 1 on 3 ln c equals to 2 on 3. Therefore, ln c equals to 2, and c must equal to e squared. So my answer for part B is therefore c equals e squared. Now, moving on to question 31. A line passes through the point P, 1, 2, and meets the axis at x and y. Show that y is equal to 2x over x minus 1. Now, when we look at this question, we need to see that this line and this line are essentially collinear. So these 3 points are collinear points. So what that means is if these 3 points are collinear, then that means that the gradient of your two intervals must equal to each other. And that's where the relationship between x and y is going to come from. Okay, so we need to figure out an expression for gradient of both intervals here. So let's do that. Let's say gradient of yp equals to gradient of px. Okay, so that's what we're going to write down first. So what's the gradient of yp? So gradient, remember, is equal to, so m is equal to rise over run. Or not run. Okay, so therefore, the gradient of yp is going to equal to rise over run. That's going to equal to negative y minus 2, which is equal to 2 minus y. Now the gradient of px is equal to rise over run as well. So that's equal to 2 over 1 minus x. So therefore, if you equate these two gradients together, you now get 2 minus y equal to 2 over 1 minus x. And from here, we can rearrange the equation. So 2 minus 2 over 1 minus x is equal to y. 1 minus x minus 2 over 1 minus x, so making the left-hand side one fraction. Okay, so therefore is equal to y. Okay. Oh, sorry, whoops. Forgot to factorize out the 2, so that should be like that. And so therefore 2 minus 2x minus 2 over 1 minus x equals to y. Therefore, y is equal to negative 2x over 1 minus x, which is equal to 2x over x minus 1. Okay, so that's what we were required to show, and that should be my answer for part A. Now, for part B, find the minimum value of the area of triangle XOY. Now, the moment we read this question, we should notice that if we are dealing with a minimum problem, this is an optimization question. And for an optimization question, what that means is we need to consider differentiation. So we know this is a diff question. We therefore need to find an expression for the area. And once we find that expression, we need to find the minimum point. So looking at our diagram, we need to find the area of triangle XOY, this triangle here. And to do that, we're going to have to do half times base times height. So the area is going to be half times x times y. Okay, now we know what y is in terms of x. That's the point of part A. So let's write that down now. So area of triangle XOY is equal to half xy. Okay, so half times base times height. And from part A, we know that y was equal to 2x over x minus 1. So that's what we're going to write. So from part A. And therefore, that's going to equal to 2x squared over 2 times x minus 1, which is just equal to x squared over x minus 1. Okay, so therefore, to find minimum, as we said before, we need to differentiate. So the derivative of x squared over x minus 1. Also, before we do that actually, let's say the area A is equal to x squared over x minus 1. This way it just looks a little bit cleaner for our working out. Therefore, A dash, we're going to have to use the quotient rule. Okay, so recall from the quotient rule that u over v dash equals u dash v minus v dash u over v squared. Okay, that's the quotient rule, which we're going to have to apply in this case, because A dash is going to have to equal to x squared derivative times x minus 1 minus by x minus 1 derivative times x squared, or over x minus 1 squared. So that's equal to 2x times x minus 1 minus by x squared all over x minus 1 squared. Keep simplifying and expanding. 2x squared minus 2x minus x squared over x minus 1 squared. That's going to finally equal to, or simplify to, x squared minus 2x over x minus 1 squared. Okay, so that's going to be my first derivative. So therefore, to find my start point, therefore, stationary point occurs when a dash equals to 0. Therefore, looking at my derivative, my numerator must equal to 0. So x squared minus 2x must equal to 0. X times x minus 2 is equal to 0. Now, x cannot equal to 0, right? You can't have a triangle with base length 0. So therefore, x equals to 2 only, because x cannot equal 0. So x equals 2 is my only stationary point. And let's add a page down here, just because we need some extra space. So since x equals 2 is our only stationary point, we now need to determine and confirm it is a minimum turning point. So we have two options. We can either differentiate again, or we can just use a sign table. Now in this question here, it's really quite annoying if we have to differentiate again, because we have to use quotient rule a second time. And no one likes using the quotient rule. So in my opinion, it is easier and more efficient if we just use a sign table. So let's do it like that. So sign table, x and dA on dx, or in other words, a dash. So here we have 2. Now, normally I would pick 1 and 3 because those are the easiest ones, but here's the problem. Can x equal to 1 for my first derivative? No, it can't, because the denominator cannot equal 0. So unfortunately for me, I'm going to have to pick 1.5 instead. Right, but that's okay, because when I put in 1.5 into my calculator, so subbing in 1.5 squared minus 2 times 1.5 all over 0.5 squared into my calculator, that should equal to negative 3. So therefore, this is negative 3. This is 0. Now, when I sub in x equals to 3, that's going to be 3 squared minus 2 times 3 over 2 squared. And that should equal to 3/4. So therefore, decreasing, stationary, increasing. Therefore, it is a minimum turning point. So hence, minimum area occurs when x equals to 2. And when x equals to 2, we need to find the area. So remember, the question is asking us for the area, not for the value of the x. So last step, 2 squared over 2 minus 1, that's going to equal to 4. So therefore, 2 squared over 2 minus 1 equals to 4 units squared. And that is my answer. Okay, so that's it for question 31 and question 30. Okay, question 32, last question of the paper, and overall a pretty tricky one. So, we have a reducing balance loan with an amount P dollars being borrowed for a period of N months. The interest rate is calculated at 0.25% per month, compounded monthly. Now, the question is very nice because they actually do give us the equation without wanting us to prove it, so that's pretty good. And here we say Jane borrows $200,000, so this is my principal. So this is going to be my P, okay? The loan is to be repaid in 180 monthly repayments. Therefore, N is equal to 180, all right? Show that M is equal to 1381.16. So we are required to calculate M, okay? So from here, we can say that AN, or A180 actually, must equal to 0. So after 180 months, my balance outstanding must equal to 0. So therefore, my equation now becomes 0 equals to 200,000 times 1.0025 to the power of 180 minus M times 1 plus 1.0025 to the power of 1 plus 1.0025 squared plus ... all the way until 1.0025 0.0025 to the power of 179. Okay, so that's my equation right now. Now, we should all know this from financial maths, that, as well as sequence and series, that this is a geometric progression or geometric series. So what that means is a is equal to 1. My first term is equal to 1. R, my common ratio, is 1.0025. And n is equal to 180, because there's 180 terms in here. So therefore, from here, I can say Sn, my geometric series, equals to 1.0025 to the power of n minus 1 over 1.0025 minus 1. And remember, since n is equal to 180, I can just say that's equal to 180. Right? Normally, we would have to multiply this by a as well, but since a is equal to 1 here, we don't need to consider it. Right? So in other words, simplifying my equation now, 0 equals 200,000 times 1.0025 to the power of 180 minus m times 1.0025 to the power of 180 minus 1 over 1.0025 minus 1. Okay? Now, rearranging this to make m my subject. So remember, we are concerned with m here. So let's make that my subject. M times 1.0025 to the power of 180 minus 1 over 1.0025 minus 1 is equal to 200,000 times 1.0025 to the power of 180. And then multiplying both sides by denominator and dividing both sides by numerator, we therefore get that m is equal to 200,000, 1.0025 to the power of 180 times 1.0025 minus 1 over 1.0025 to the power of 180 minus 1. Okay, now finally we can put this into our calculator, and when we put this into our calculator, we should get 1381.16. And that's our answer. Now, part B. After 100 repayments of 1381.16 have been made, the interest rate changes. Okay? At this stage, the amount owing to the nearest dollar is 100,032 cents. Jane continues to make the same monthly repayments. How many more months would Jane need to make full monthly payments? So, with this question here, we can think of it like this. I borrow money for 100 months, and then I borrow again for n number of months. I don't know how many more months, so I'm just going to leave it as n. And the amount I borrow the second time is 100,032. So what does that mean? It means my principal has now changed. So before, my principal was 200,000. But now my principal is actually $100,032, as I said before. My m is still going to be 1381.16. But my r has now changed to 0.0035. Okay, before it was 0.0025. Now it's 0.0035. So that's okay, and we also don't know what n is, so let's just put a question mark. So now, looking back at this equation, we just need to change a few things, but it pretty much remains the same. Okay, and it's still a geometric series. Alright, so therefore we say, therefore, an equals to the principal times 1.0035 to the power of n minus by m, which we calculated to be 1381.16, times by the geometric series. So now it's going to be 1.0035 to the power of n minus 1 over 1.0035 minus 1. Okay, now from here, I want my amount outstanding at the end to equal to 0. Okay, so I don't want to owe any money after this, so therefore I'm going to make it 0. So 0 equals to $100,032 times 1.0035 to the power of n minus 1381.16 times 1.0035 to the power of n minus 1 over 0.0035. So now I need to figure it out. I need to solve for n. To solve for n, I should probably start expanding and simplifying, especially this part of my equation. So therefore, let's do that. Let's say 0 equals to 100,032, 1.0035 to the power of n minus, now putting this into my calculator, 1381.16 divided by 0.0035, that should equal to 394,617.14. Okay, times by 1.0035 to the power of n minus 1. Now expanding this bracket, that's going to be our last step. That's equal to 100,032, 1.0035 to the power of n minus 394,617.14 times 1.0035 to the power of n plus 394,617.14. Okay, so it's a pretty tedious amount of working, but unfortunately there's no shortcuts here. Alright, so now that we have this, we can finally make 1.0035 to the power of n my subject. Okay, so 100,032 subtracted by 394,617.14, that's going to equal to negative 294,585.14. So therefore, now that everything is simplified and cancelled out, I can now make it the subject, but I'm going to need some extra space. So what I'm going to do here is I'm going to copy our working out so far onto a blank page. So bear with me for a second. Copy. We're going to add a page down here. Okay, so this is my working out from before. Now, as we said, we are now going to simplify or make 1.0035 to the power of n the subject of this line. So therefore, 294,585.14, 1.0035 to the power of n is equal to 394,617.14. And from here, 1.0035 to the power of n is equal to 394,617.14 divided by 294,585.14. And from here, we can finally use logarithms. So therefore, n is equal to log base 1.0035, 394,617.14 over 294,585.14. Now, when we use our calculator, we are unfortunately not able to choose the base. So our calculator only has base 10 and base e. So what that means is we're going to have to use change of base logarithm law. So therefore, this is going to have to simplify into ln. So putting this into our calculator as well, because we cannot be bothered to write this down anymore. When we put this into our calculator, this fraction should now become ln 1.339569 over ln 1.0035. So this is change of base law. And that's equal to 83.67. Now the question asks us, however, for how many full months or full monthly repayments. So instead of rounding up, we actually should be rounding down because we're asked for full months. So therefore, my answer is actually meant to be 83 months for part B. Okay, so rounding down because we are asked for complete monthly repayments. All right, part C, last one. The final repayment will be less than 1381.16. How much would Jane need to pay in the final repayment? So this is actually a very tricky question. It seems very easy because all we need to think of is after 83 repayments, how much do I owe after 83? So after 83 repayments, we let n equals to 83. So A of 83 is now going to equal to 100,032 times 1.035 to the power of 83 minus 1381.16 times 1.0035 to the power of 83. So this is just subbing in n equals 83. So we are using this equation we had before. Okay, now when you sub that into your calculator, you should just get 928.29. And most students, I would say, a good chunk, 90%, would just stop there. But what have we not considered? The reason why this question is quite tricky, and the reason why this one is actually very hard to get full marks in, is because this is after 83 months. But my fourth repayment, so this is the amount outstanding in my loan after 83 months. My 84th repayment, however, is 1 month later or 1 month after this. And during this month, remember that interest is compounded. So during this month, I still have to generate interest. So what that means for me is I actually have to pay in my last repayment. I actually have to pay 928.29 times 1.0035 because of that interest. So therefore, that's going to equal to $931.54. So my final answer is 931.54. So it's a very tricky question because we had to just remember to multiply by 1.0035. All right, but that should be it. So that's it for the paper.